So things are shared up until the very last possible moment. Does that answer your question?
So where does the geometry come from? Is there a mechanical process to pick that off of the satellite imagery?
That's a good question. It used to come from people we would license the data from. Atlas was one of our vendors for data. So it would be usually just pairs of lat long points. And it would define that outline of something. And for buildings, we would often collect a lot of that data ourselves. And it can be extrapolated from satellite imagery. So actually, just the other day, we released like 100,000 buildings or something. We just added that we auto-generated from satellite imagery. So I'm pretty sure like most people's houses now should actually be in there, but it'll have like an extra garage or something. Like, it seems like a tree or a car, and things like maybe that's a house or something. So like houses will have like extra additions. You might find that your property value just went. And those are automatically generated from satellite imagery. We also have a lot of, but recently we've been bringing a lot of the geometry in-house, for just because we didn't want to have a lot of vendors that we were relying on. So per country, we've had projects to go get all of our own data for like France, and we would have extra people in France, people who work for Google, people who are volunteers, adding, my house, my street, my city, my coffee shop I go to. And we have all this information now that is sourced ourselves. So we have, it's called user-generated content or user source. So now I think something like 60% of our content is now all user source. And we have people on the ground, we have people generating it and people checking it and constantly updating it.
So you spoke earlier about how the mobile versions are a little more constrained in how much data they can get, but with a lot of devices going 4G, and the rendering can be much faster. So are you guys moving from how much data you can get to how small can that data be? Because most people are going to these limited data plans.
So are we trying to get them to these files to be small?
Yeah, and shrinking the size so it's not interfere with people's plans.
I don't know. That's a good question. I don't work a lot with the mobile people, so they would probably.
So if you're sending down vector images basically to be rendered on the client, that's going to involve a lot more CPU for the lesser amount of bandwidth that you're transmitting. Have you guys noticed any issues causing like client-side performance stuff from the fact that the client is having to basically rasterize all these vector images that you're sending down?
It's not rasterizing.
It's not rasterizing. Okay.
No, I mean in terms of the graphics processor, it's not. I didn't think of it as rasterization, but like as soon as it rasterizes, it throws it away. So I mean, it's not keeping it.
But when you were doing the demo earlier regarding drawing the curves and roads and having to draw like the links and the rectangles and whatnot, you're saying that those are actually sent down as part of the vector image, or are those generated from the vector image on the client?
Actually, I don't know the answer to that.
Okay.
That'd be interesting to know. But if it does have to do the preparation, taking the segments and adding the joins, that would be a one-time operation, and it would happen in the CPU. You're right. So client-side performance is a huge concern for us. So we have we are huge proponents of the Chrome developer tools. So has anyone here used the Chrome developer tools for writing web apps? Have you used the profiler and the tracing? So you see like you can take a function, a JavaScript function, and profile it in Chrome, and it tells you how many times it was called, and the average, and the min, and the max time. So when we are rendering, we have about 16 milliseconds to get a frame out. Otherwise, you're going to see frames dropping, because that 16 milliseconds correlates to, I think it's either 60 or 30 frames per second. I think we like to be at 60. I think 30 is like the minimum. So ideally, we would get a frame out of 60 milliseconds. And if you have to have, and JavaScript is running as a single process, a single thread. You can't run multiple functions at the same time. So if you have a JavaScript function that's running, we have to have all the functions done after 60 milliseconds so we can put the data onto the GPU buffer and have it rendered. And then we can come back, next frame, do a little more work. Maybe we're downloading new tiles, or maybe we're parsing the new tiles and getting them ready because the user's panning. So every 16 milliseconds, we're like, okay, do some work, stop. Okay, do some more work, stop. Do some more work. So getting the client to be performant and making sure that we're not running over our frames is a constant battle, but it's something we can manage. So that's the kind of client-side performance problems we have. In the back?
I've noticed using both MapsGL and regular maps that if I go and zoom in all the way to a certain area, I get tiles and can see everything that's fine. And then I go somewhere else, look at some other places, and then I go back to the same zoom level at the same location. And it seems like I need to, I definitely need to redraw the tiles, but it also seems like maybe I need to reinitiate a download of those tiles. Do you guys do any caching on the front end to help to mitigate that, or is it sort of on demand?
But we definitely do caching. We're using several different types of caching. In the first case, we would be actually saving that tiles data in a JavaScript object, and storing it in an application side cache, and that is affected in terms of least recently used. So if you go somewhere else, the old tiles will be evicted. Go somewhere else, and those will be evicted. Come back, cache hit miss. Then we'll also use the browser cache and any server-side caching as available. But that's basically the caching problem. And it's kind of hard because you don't, when you're running in a browser, you don't really know how much memory you have to work with. So we kind of have a hard limit. We won't go over like a couple megabytes in just the application memory across all clients. Because you don't know whether your client has 10 gigabytes of memory or 500K. Probably has more than 500. Any other questions?
So the first goal is to reduce the amount of bandwidth used and give a smoother experience to the mobile user, for argument's sake.
That's true.
Once you have this capability, though, it would seem that you have more client-side rendering capabilities and vector capabilities. Are there other things that you want to do with the interface that would be prohibitive on the
Raster maps?
Yeah, on the raster base?
Yeah.
That you can comment on it.
That I can comment on. Well, I mean, I'll just reiterate the buildings, because I think that's a really cool example. Like, I think that's the first thing that really wowed me about MapsGL. It was like, this is like something different. This is like a video game or something. Let me think of an example that I can mention that answers your question. Well, I think a good example might be showing search results. Because in Google Maps right now, when you do a search, put the little pin, it says like A, B, C, D. But those pins are very separate from the map. You know, they don't seem like they fit with the map. So it would be really nice if we could, like, maybe make the pin not overlap any labels that are on the map already. So let's say like a pin goes down and it clobbers a street. We could hide that label, or move the label, or move the pin, maybe. So it's like saying like, yeah, your church is over here, but the pin's over here, so it's like, so I think that's an example. So changing the map, anytime you want to change the map, put something on, take something off. That's where having vector maps really comes in handy.
You try to strike a balance between integration of new sort of JavaScript technologies that could help performance along with sort of just wide support for using WebGL. I asked this because you're talking about performance issues such as how you can't use processes, but you're starting to see browsers start to support web workers, which can help mitigate that. Is that something you try to integrate, or is there normally just more of a focus on widest support possible for WebGL?
Well, it's funny. It's like WebGL has pretty narrow support, to be honest, like 50% of browsers, 50% of users in it. We have not explored web workers, to my knowledge. I don't know if anyone has, has a crazy branch of Google Maps that uses web workers. I think that would be really interesting because we do a lot of like background type stuff. Like when you download the tile, we have to extract all the information from a lot of parsing that happens from the tile to get the buildings and the roads and the labels and the colors and all the stuff. So I think that could definitely be the kind of thing that has to happen in a web worker. In case anyone else is wondering what a web worker is, it's a background JavaScript process in the browser that can't interact with the window. So you kind of like tell it to go do something, and it does something, and it sends a message back when it's done. But while it's doing that, it can't be responsible for user interaction or output of, or like manipulating the browser window, drawing anything. It can't do any sort of rendering, anything like that. Does that answer your question?
Yeah.
So we haven't tried it, that's my knowledge. But it'd be really useful. And I think maybe when it becomes more common, we will use it. I'd certainly like to use it.
All right. I was just curious because I know it has even less support than WebGL in browsers
yes.
currently. So.
That's probably why we do it. But we like to use our own products. We like to use Chrome. I think like everyone that I work with uses Chrome as their development environment. So we are definitely in favor of a lot more people using Chrome.
You mentioned you have a database of the world. What kind of a data store do you use for that?
Actually, off the top of my head, I don't know what it's backed by. But if I had to guess, I would say Bigtable. So Bigtable is in terms of Google technologies, it's pretty well publicized. Lots of papers published about Bigtable. It's a general purpose, very large data store. If you don't already know about it, you can find a lot more about it.
It's on App Engine, right?
It doesn't run. I think it backs App Engine in the App Engine's data store, yeah. And I can look it up, and if I'm not right, I'll actually. Did you have a question? Anyone else? Okay. Okay. So I'm going to talk a little bit more about engineering at Google and being a Googler. So I've been a Googler twice. I was an intern. Now I'm a full-timer. Google back in 2006 was a little different than it is now, but it's still a great place to work. I think in some places it's a lot better for employees in terms of like the benefits and the way the company is structured. It's a lot more the sort of like efforts that the effort that Google puts into products is a lot more concentrated now. We have sort of divided the company up into different product areas for, like Google Plus is a good example, and Google Maps is a good example. So things that didn't line up with those primary Google efforts have been either shuffled or canceled, or things that weren't being very productive, things that weren't making a big difference have gone by the wayside, and now people are working. We try to say that people are working on stuff that matters. But before I get to that, if you want to know more about getting in touch with Google as a student and kind of things that Google can do for students, such as scholarships and internships, go there. And if you want to be contacted by someone from Google after this session, go here. Big C. That's a form where you can give us your email address and stuff like that. I'll leave that up there so if anyone wants to copy it. There's the dot. Cool things that matter, right? So we work on huge things. I I get kind of scared by this, that I work on Google Maps and it's like the entire world. So I just, I have that little window of Seattle, and I try to keep my browser open to that one and not try to like go anywhere else, because it is huge and scary to me sometimes. But this is a product that serves billions of people, and we have other products that serve billions of people, and it's amazing. We started with search. Search is awesome. Who uses Google search?
Small company.
And now 15 years later, we're not just one of the largest tech companies, but we're trying to push web software and to be more advanced and more user-friendly, and to let people do new things that they couldn't do before. So Google, not many company names are a verb. I mean, you can Google something, but I don't think you can Microsoft something. Is anyone Facebook stuff?
I'm sorry, have you seen the product placement for Bing?
You can ding it.
Force, yeah. Somebody bings it, and you're just like, it just doesn't, it gives you this verbal whiplash when you hear it. It just doesn't sound right.
I think you do Facebook, but Google's actually like in the dictionary. It's that cool. And we have these tons of products, and there's a lot of challenge in trying to create a single user experience behind Googling. So this is just a few of our product areas, but this is sort of the 8 largest product areas that we have. Let's see. So Chrome also includes things like Google Docs. This is Google Docs, Google Drive, Maps. That's what I work on. Android includes like developing mobile applications for Android, and also developing the phone software itself. That's where we get all our money from. That's a good one. A lot of people work in ads. You might think of ads as just like putting text up, but it's a huge engineering area. And to say like you are working on the part of the company that makes money, sometimes that's like a positive thing. A lot of people work on social, and there's still like a lot of research and experimentation that happens in areas such as search. So we're constantly tweaking search to be, you might go to search one day and get slightly different results, and that's probably because some researcher on the other end decided to run an experiment on your search results where they put like this thing up here, or like these are different, and they're trying to see like how can manipulating the results lead to a better user experience, like better click through on different, or less people trying different searches. So a few numbers. I mentioned the user-generated maps before. That's what Project Truth is. So we have these, we have our own cars driving around gathering street-level data. So they're gathering GPS coordinates of streets, intersections, where our business is exactly, where's their storefront, where's their front door. So we've driven something like 5 million miles. We have something like, what was the number? 10 billion? 10 billion Google queries every month. That's like, more than the number of people in the whole world. And every Google, most Google products are translated into multiple languages. We have something like 63 official languages. Like I could probably name like 10 languages. I think if we, together this whole room, we could name like 20. We try. They have 63 languages. I think, so this is where our Google offices are. We have offices everywhere. Every dot on this map is an office. These are just the ones in North America. So I work up here. There's 2 offices up here, actually, Seattle and Kirkland. The main offices are here. And we have offices everywhere. New York is a big office. Chicago is a big office. Waterloo is a big office. We have, what's this slide bar? I don't know what this slide's
Oh,
this is kind of the getting into more of like being a Google. These are a lot of the benefits that we get. We have maternity and paternity leave. I have a colleague right now who his wife is also a Googler, so his wife took I think 8 months off to be with their newborn, and then he's taking the second 8 months off, or maybe not 8 months, maybe less than that. But so she took her maternity leave and then came back to Google, and then he went on his paternity leave to care for the child. I think that's really cool. I wish I had that kind of benefit when I had kids. I mean, I'm sure everyone has heard of the food, but just in my office, we have in Seattle, I think there's like 450 people on site, and we have one cafe that serves breakfast, lunch, and dinner, and another one that serves breakfast and lunch. And it's not like reheated stuff, it's all like cooked by real chefs and prepared on premises. I think one of the great benefits is gift matching. So if you are feeling philanthropic and want to donate like a couple $1,000s to your favorite charity, Google will match that. I think up to a certain amount. I think it's up to like $8,000. So if you want to donate money to like a relief effort, Google will match those. Tons of benefits. I could go on. A little bit about careers at Google. You are expected to be sort of self-driven in your career at Google. So there's lots of resources for developing your career. There's mentorship programs. There's an internal jobs board, so if you're bored with your job, you can go to see who's hiring and go anywhere else in the company. Promotions are an interesting case. Promotions are not so much recommended by your manager, but by your peers actually. So you can, like once a year, go up for promotion, or I think twice a year, and then you can solicit your peers to give you feedback. So you better be nice to your peers and do nice things for them, and bring them cupcakes, and they'll write nice things about you and say, John is really grateful, or he should totally be a senior engineer, or not. Well, not because I didn't go for promotion, because I just started there. And as an employee, you have information to pretty much all of Google's collective consciousness. You have every tech talk that's ever been recorded in the company is available on YouTube. You have documentation collaboration is a huge thing, so people are constantly working on documents together in Google Docs, writing design docs, writing questions, writing answers, taking notes, and all this is published and shareable within the entire company. One thing I like is open calendars, so you can go to see anyone's calendar in the entire company. You can go see the CEO's calendar, see what he's doing today, see if he's got an open time. I can schedule a meeting with him. You might say no, but it's useful with your boss and with your peers to see like when's a good time that we could have a meeting. Or where is my boss right now? Why isn't she? And dog fooding, I think, is another good thing. Does anyone know what dog fooding is?
What dog food is?
What's dog fooding?
It's the food that dogs eat.
What's dog fooding?
It's when basically the employees use a new product they're working on to test it in-house.
That's right. So a good example might be some new iOS app that no one knows about in this room, but I know about. I don't actually have it on my phone, but I could if I wanted to. So that's what dog fooding is, and it's really exciting and it's really scary because like they're trusting you with something which is about to be released, but isn't released yet. That slide just says Jones. So these are the types of jobs that a new hire could go into. SWE, software engineer, that's me. I develop stuff. You could be a product manager, which would be sort of managing a product development process. So we would have like several different PMs just on Google Maps developing different features, developing different teams. User experience people, they are the ones who say how it should work, how it should look, how it should feel. Very important, especially at Google, we have pretty high user experience standards. And we have a lot of IT responsibility. And this isn't like plugging in mice and stuff. This is like developing next generation video conferencing technology and working in data centers and working on the actual hardware that runs Google. As far as employees doing their employee level IT, we have in every Google office these places called tech stops where if you need help with your hardware or your software setup, you go there. They don't come to you, and you actually have to interact with someone and get your problem solved on your time and on their time. So it's not like you can just complain and say, my email doesn't work. You have to go talk to someone. I think that's a good thing. So what does a software engineer do? Pretty much they build awesome stuff all the time. We also have engineers who work just in test. So they are not doing just like, writing tests, but they're also testing performance. They're finding when things break. This is a very important thing. I think we just had App Engine down for a couple hours yesterday. It was embarrassing. And this is the kind of thing that engineers and tests would be focused on. That was a load issue, so I don't know if anyone's heard about it, but there was a increased load in one of the data centers for App Engine, and we tried to restart the load balancers in just that data center, and that took that one down, increased the load in the other ones, and eventually the load got over the capacity, and the entire infrastructure for App Engine became, I think it was like 50% of queries, requests were being dropped. Eventually I had to take the entire thing down, bring it up slowly over like 4 hours, and slowly start trickling in traffic until we were able to bring everything back up to 100%. And the people that were doing that were these guys, the site reliability engineers. They're the ones that are actually managing production Google services. They are on call 24/7. Well, not 24/7, but if you're at SRE, you'll be on call for 24 hours, and you'll go off, and you'll go on, and you'll go off. For every single product area, for search, there'll be a whole team of SREs. There'll be even for backend systems, so systems that would never see user interaction, like backend databases. Even if it goes, even if that goes down, you're impacting other Google employees. You're impacting sales or ad operations. So there'll be SREs for that. And it's a very exciting job because you come in on Monday morning and you find out what's on fire. You find out what did you screw up or what did someone else screw up. And so you're constantly reacting to like real world emergencies rather than like when someone introduces like a bug that's like, oh, the sky is falling, but it's not really like a big deal. You just fix it. It goes out in the next production push. But when your servers are falling over and load balancers are dying, that's a real problem, and you have to fix it like in an hour. So this is the application process. If you're interested, we usually have I think for every applicant there'll be 2 phone screens if you're interested, and that usually goes to either on-site interviews, like a whole day of on-site interviews for full-time positions. For interns, it would be 1 interview with the host, whoever's sponsoring you as an intern, and from that point it usually, hopefully, will result in an offer from the hiring committee. So even interns will go through hiring committee process. This is just kind of describing what APMs do. me see it. This is more talking about what IT does. What user experience people do. I think this is a really cool, user experience is a really cool area for people interested more in like human-computer interaction. It's much more of like an academic